Let's start with our discussion on this topic from algebra called remainder and factor theorems. Before we get into these theorems per se, let's just understand a small concept. Suppose if I have a polynomial 6x cubed minus 3x squared plus 8x minus 5, right? As you can see, this is a polynomial with a variable x, and so the value of this polynomial will depend on the value of x. So this can be termed as a function of x and denoted by f of x. So this f bracket x is read as f of x, right? So it tells you that's a function where x is the variable on which its value is going to depend. Okay, and now suppose if I consider the value of x as 2, I can find the value of this expression, right? All I need to do is I need to substitute 2 instead of x. So I can call this as f of 2, which is equal to 6 into 2 square minus 3, 6 into 2 cube minus 3 into 2 square plus 8 into 2 minus 5, right? It's just substituting the value of 2 wherever there's an x in the expression, okay? In a similar vein, suppose if I have a expression with y as a primary variable, right? I can call that as g of y, which is equal to 2y cubed minus 3y plus 1 in this example. And suppose if I want to find the value of this expression when y is equal to minus 1, I can say I just need to substitute minus 1 instead of y all over the expression, and I can solve for it, right? It's a simple idea which would be repeated quite often throughout this chapter, so it'd be good to know about it, right? So keeping that aside, let's start with understanding the remainder theorem, right? So first, let's just see what's the statement of the remainder theorem. It tells us that if f of x, which is a polynomial in x, is divided by x minus a, the remainder is equal to f of a. Okay, so let's try to understand this with an example, this remainder theorem with an example. Okay, so if I have a polynomial from before, f of x, which is 6x cubed minus 3x squared plus 8x minus 5, and I'm dividing it by x minus 3, right? I just need to find the remainder. We're not really concerned about the quotient right now. Also, as the name suggests, the remainder theorem will give us the value of the remainder, right? So if I'm interested in finding the remainder theorem is basically a shortcut method or a trick which will give me the remainder without actually performing the division, right? So let's see how let's see the steps that we're going to use. So the first thing we need to do is we need to put the divisor equal to 0 and solve the equation and get the value for the variable. So x minus 3 here is my divisor, so you set that equal to 0. So to solve this equation, take the 3 to the other side. This gives me the value of my variable x as 3, right? Now remember this value, we're going to use it later on in step 2, right? Which tells us to substitute the value of the variable obtained in step 1 in the given polynomial and simplify it to get the required remainder. So what that means is, according to remainder theorem, this value of x which I have received, all right, if I am to substitute that in the given polynomial, this is my given polynomial, right, I should get the remainder. So I could say now that the remainder, right, is equal to nothing but, so f of x is my polynomial. Now instead of x, I need to write, instead of x, I'll just substitute 3, and this should give me the value of the remainder. So the value of my remainder now becomes 6 times 3 cubed minus 3 times 3 square plus 8 times 3 minus 5, right? So if I am to solve this, over here, I will get the remainder of f of x being divided by x minus 3, right? In the next few videos, we'll be solving sums which are going to be the application of this remainder theorem, and hopefully the idea gets more and more clear as we solve the sums, right?